السلام عليكم ورحمة الله وبركاته.
عليكم السلام.
طيب، بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على رسولنا محمد وعلى آله وصحبه أجمعين. طيب، بسم الله، نبدأ إن شاء الله. We're running out of time, we have less time and we are still slightly late, so I will start right away. Regarding the quiz 1, you all did the quiz 1 and the results are out. The average for the quiz was 77 out of 100 for information. We're not going to say much about it. We'll continue with our discussion in chapter 3. Right. Last thing I talked about in chapter 3 was if you have a chemical reaction like this chemical reaction or any other chemical reaction, okay, then whenever you have a chemical reaction like this chemical reaction, what's this reaction? Sodium carbonate, right, react with H3C6H5O7 to give you CO2, H2O, and sodium I think acetate, sodium bicarbonate, sodium citric acid. Okay, so sodium carbonate or bicarbonate react with citric acid to give you sodium citrate. Sodium citrate. No problem. Whenever you have a chemical reaction like this, then you know from the chemical reaction that you react 3 moles of this one, whatever is this, react with 1 mole of this one to give you 3 mole of this one and 3 mole of water and 1 mole of sodium acetate. We know this whenever you keep it in mind, and actually I want you always to write it and find this relation. It's very easy to find this relation. Now, at the same time also, you can change this to gram, but you don't have to, except if you know that you're going to use them. Otherwise, you don't have to calculate the molecular mass of any of these things. Now, if you have 1 gram of sodium carbonate, then how many grams of citric acid you need to make the reaction complete? What do you think? You should write 192.12 gram H3C6H5O7 react with 3 times 84.01 gram NaHCO3, and this will give you gram NaHCO3 will go with gram NaHCO3, and you can go ahead and calculate what's the result. Use your calculator and tell me what's the result.
64.
64? Impossible. No, it's not possible. It's not 64. It cannot be.
0.76.
0.76.
Are you sure 0?
Yeah, 0.76.
0.76 gram H3C6 H5O7. Maybe I believe you this way. All right. So just looking at the reaction, if I give you, I told you that whenever you have a chemical reaction, you can always rate things by what? Yes, by mole. You have to calculate number of moles. And the number of moles is you can get from the reaction. And then 3 here, 3 here, 1 here, 1 here. You get this relation of the mole by the chemical reaction itself. You can change it to gram if you want for your calculation, if you want. So this time I needed these two, so I did the, what's the mass of this one? What's the mass of this one? I got it from the periodic table, and then I calculated for this gram. On the other hand, if I have 1 gram H3 C6 H5O7, then how many grams in a HCO3 I'm going to make? What should I do?
Multiply it by 3.
3 times
84.
84.01 gram NaHCO3 and divide by 192.12 gram H3C6H5O7. All right, and then actually this unit will go with this unit, and you have the answer. You have the answer.
Yes.
What is it?
1.31.
1.31 gram NaHCO3. Very good. So, do you know how to rate things by chemical equation now?
Yes.
Do you know how to rate things by chemical reaction? Good. Next, let me ask you a very simple question. Now, I told you here that we have 1 gram of this one and 1 gram of this one. What if I went to the lab, I go to lab and mix 1 gram NaHCO3 with 1 gram H3 C6H5O7. All right? Then what will happen?
ما راح يصير شيء.
No.
No, part of it just.
Yes, part of it. See, in the first reaction, and here I told you I have 1 gram of NaHCO3 and I have a lot or whatever of, I have the same amount that will react with it from this one, and I found that I need 0.76 gram. So I need 0.76 gram to react completely with 1 gram of NaHCO3. If I have 1 gram of this one, I need 1.13 of NaHCO3. What if I have 1 gram of this one and 1 gram of this one? The 1 gram of this one will react, sorry, the 1 gram of NaHCO3 will react with 0.76 gram only, and the rest will be extra. It will not be used. So if I have 1 gram of NaHCO3, it will not react with the full 1 gram. it will react 1 gram of NaHCO3 will react with only 0.76 gram H3C6 H5O7 because I did this calculation. All right, what will happen to the rest?
Extra.
Well, how much is it, by the way?
Divide the numbers.
No, that divide.
0.24.
0.24.
Yes, and extra 0.24 gram H3C6O7 will not be used. Will not be used. Is this clear? So whenever you have a chemical reaction, then you can relate things by number of moles. And if you need, you can change them also to gram. Then if I give you two things reacting with each other, you should calculate how much of this one need of this one, and how much of this one need of this one. And this way you can say that actually, in this case, the 1 gram of, which is the 1 gram of this one, we call it limiting reactant. Limiting reactant. What do you mean by limiting reactant? This means it will finish before the other one. That's why, even though we have 1 gram of this one, 1 gram of this one, 1 gram will react only with 0.76 gram of H3C6 H5O7. The rest, then 0.24 will not react. This will be extra. And that's why NaHCO3 is called limiting, and H3C6 H5O7 is called excess. Excess reactant, and the amount of the excess reactant will be 0.24. I hope this is clear. Now, let's solve this problem, which is the same reaction. So I'm going to use the same reaction, right? This reaction. All right? And keep this reaction in your mind because we want to solve it. If we have 1.7 gram of sodium bicarbonate and 1 gram of citric acid, which one is the limiting reactant? Which one is the limiting reactant? Okay, I go back here and I will erase everything in here. All right, good. Now, we're still in this reaction. Now, and you have all the information here. We have 1 gram, 1.7 gram of this one. I want to react it with 1.0 gram H3C6 H5O7, and this one gram NaHCO3. All right, if I go to the lab and react 1 gram of this one with 1.7 gram of this one, from where did I? This is the reaction. That's before we read the reaction. This information, we got it from the chemical equation, from this chemical equation. I went to the lab. It says here, I took 1.7 gram of sodium bicarbonate and put it with 1 gram of citric acid, like here. Then, which one is the limiting reactant? What should you do? You should do the calculation for both of them. 1.7 gram NaHCO3 needs how much of citric acid of this one? If I have 1.7 gram of this one, how much of this one is needed?
Multiply.
Multiply by what and by
192.
192.12 gram H3C6H5O7 divided by
1.6.
3 times 84.01 gram NaHCO3. And this will tell you how much we need. Go ahead, do the calculation.
1.29.
1.29 gram H3C6H5O7. All right, that is if I have complete reaction, right? But what I have, in this case, I have only 1 gram. Do I have 1.29? No, I have only 1.0 gram H3C6H5O7. What does that mean? That this one now is called what?
Limiting.
Limiting reactant. Then let's try with this compound now. How much of sodium HCO3 do I need? If I have 1.0 gram H3C6H5O7, how much of sodium bicarbonate do I need? What should I do?
Multiply 3.
3 times 84.01 gram NaHCO3 divided by 192.12 gram H3C6H5O7. And this will give you how much?
1.31.
1.31 gram sodium. NaHCO3. What does that mean?
This is the axis.
We have
What's the axis?
39.
What's the axis? How much?
1.31.
No.
It is
No.
39 gram.
because we
300 gram. Yes. So what is going to react is 1.31 will react, but I have 1.7 to start with. So only 1.31 gram NaHCO3 will react with what?
With H3C6.
With the 1 gram, 1.0 gram H3C6H5O7 and 0.39 gram NaHCO3 will be extra or excess. Is this clear?
Yes.
Excess, not used. So we are going to have 0.39. From where we got this 0.39? It's actually this 1.7 minus 1.31, which is that we use in the reaction, and that's what we start with. So in this case, it's 0.39. So which one is the limiting reactant?
Citric acid.
1 gram of citric acid is the limiting reactant. Which one is the excess? Sodium bicarbonate. How much of the sodium bicarbonate is excess?
0.39.
You got it? I hope so. Good. Done with this one. I hope you got it. Now, assume that I will talk about now theoretical yield and experimental yield. What do you mean by, what's the meaning of yield? What's the meaning of yield?
محصول أو شيء زي كذا.
Yes. What is it? How much
ناتج.
produced? Yield means how much is produced. How much is produced. That's the meaning of yield. Clear? All right. What do you mean by theoretical?
In theory, not in like a practical way.
By theory or calculation. All right. We have also another thing which is called actual yield. What do you mean by yield?
Produced.
Produced. What do you mean by actual?
Like what happened
Yes.
in real life.
Chemistry. Actual means experimental also. Experimental, by experiment, how much you got it. All right. Now, this is called experimental yield. And if I want to calculate the percent yield, I should divide actual yield by theoretical yield, and of course, the next, what should I do? Multiply by what?
Yeah,
Times 100%.
By 100. I want you to memorize now these words: yield, which means how much produced. I want you to know what theoretical yield means by calculation. Actual, what does it mean actual? By experiment. All right. And what's percent yield? It's actual divided by theoretical times 100. All right. Okay. Let's go back to our example. We are still in the same example, which we spend a lot of time to react with it. Okay. Now, assume that I have this reaction in which, let's see. Okay, take these numbers because I will raise them, but I will ask you about the Binawayan. All right? Okay. Copy all these numbers, and then let's go back and erase this one more time. Okay, if I have this reaction, okay, if I react 1.7 gram of NaHCO3 with what was it, Was 12.7? Let me remember.
1.0.
Yeah, 1.0, exactly. 1.0 gram of H3C6H5O7. We did the calculation. Which one is the limiting reactant?
H3, C6, H5, O7. Citric acid.
Is the limiting.
Yes.
It is limiting. All right?
Yeah.
Okay. Why? Because this one needs how much of this one?
1.29.
1.29. Actually, 1.29 gram NaHCO3 needed, and 0.29, 0.29.
No, Doctor. 1.31.
1.31. You are absolutely right. Yes. Just a second.
And the extra is 0.39.
1.31.
Yeah, 1.31 heated and the extra is
1.39 extra. Excess. Gram NaHCO3 excess. Clear? I hope this is clear and you know how to do it exactly. Now, when you want to do your calculation after that, you have to do everything with the limiting reactant, because that's the maximum that you're going to have. Okay, if I have 1.0 gram H3C6H5O7, then how many grams of water I'm going to produce? How many grams of water I'm going to produce?
multiply
Should I multiply by what and divide by what?
3 multiplied by 18.02.
3 times 18.02 gram H2O, divide by
3 times 84.01
3
grams.
times 84.01 gram
HCO3.
NaHCO3. And I need an answer.
0.21.
Is it 0.21? 0.21. Sure? Who also got the same answer?
Yes.
Very good. Now, 0.21 gram H2O will be produced in this reaction. Clear? We call this 0.21, we call it theoretical yield. Why did they call it theoretical yield?
Because we got it from the equation.
Got it the number.
The calculation.
Yes.
Okay? Because we did it by calculation. Now, listen
Doctor,
to, yes.
why in the equation there is NaHCO3 down, the denominator, and it's multiplied by HC6, H5O7?
What again? And here you mean?
Yeah, it's 1 gram H3C6, H5O7.
Yes, it's wrong.
And in the denominator is NaHCO3.
We divide with another compound, not with the same compound.
Of course. Yes, yes. Oh, I'm not concentrating myself. Sorry. Yes. Of course. Oh, this is wrong. Oh, you're so okay. Of course. Here we are using this compound. How come we multiply? We should divide this now by 192.12 gram H3C6H5O7 because I want to get this unit with this unit. So I'm sorry for putting that one. I was not in concentrate. Okay, what's the answer now?
0.31.
0.31. Who else got the same answer?
0.28.
0.28.
28, doctor.
28 or 18? I don't know what's the answer.
28.
28?
Yes.
0.28 gram H2O. Who got the same answer also?
Yes.
Yes, that's correct.
This is called now theoretical yield. Theoretical yield. All right. So if I mix 1.7 gram NaHCO3 with 1 gram of H3C6H5O7, what will happen? The 1 gram of H3C6H5O7 will react with only 1.3 gram, 1.31 gram of NaHCO3, and it will make 0.28 gram of H2O. And that's why we call this one limiting reactant. And that's why we call the 0.39 excess. This means it will not be used in the reaction. Is this clear? Very good. Now, after that, we called 0.28 theoretical yield. Let's assume I went to the lab and I react 1.7 gram NaHCO3 with and 1.0 gram H3C6H5O7. Then which one is the limiting reactant?
H3C6H5O7
is the limiting reactant, and this one will be extra. How much of this one will be extra?
0.39
excess. And how much water I'm going to produce? 0.28. All right, 0.28. But when I did the reaction, I was not very good in the lab, and I got only 0.21 gram H2O. What do we call the 0.21 gram H2O?
Actually,
Actual. You got it? I'm supposed to get 0.28, but what I get is 0.21. And then, can you calculate the percent yield? Quickly.
75.
75.
0.21 divided by 0.28 times
times 175.
Is this clear?
Doctor.
Yes.
The actual, how did you get it?
Yeah, as I said, I did the experiment myself and I got 0.21. Let's assume that I gave you these things and you went to the lab and you were better than me in doing work and you got 0.23. Then this is my actual yield, but for you, you were a better working in the lab and you got 0.23. Then the percent yield of your work will be better than my work. Is this clear?
So if there's no mistake in doing the experiment, the actual yield will be exactly the same of
Like
theoretical.
what's the maximum that you can get? The maximum yield?
0.1.
100%.
100, yeah.
And you get 101%. Never. This, yes, you're right. Always the actual yield, it should be at least يعني less than the theoretical yield. The maximum it can reach is less theoretical yield. But it should be less. And this one, it will be, the theoretical yield will be the same for all of us. For me and for you, because it's by calculation. But the 0.21, it depends on the person. Maybe I have two students. One of them is very good in doing work, and the other student is not good in doing the work. And the good student got 0.25 gram. And the bad student will not get 0.025. Let's assume that he got 0.19 or 18 or 17 gram. See, if I want to calculate the percent yield for the first one, I should divide this 0.25 by 0.28 times 100. And the other student, same thing, 0.17 divided by what? 0.28 times 100. So the actual yield, the theoretical yield is the same for both of them because we did it by calculation. But the actual yield for this good student, it was 0.25, and for the bad student, it was 0.17 only. Got it? I hope so. Let's solve this problem then. Okay, aspirin. Okay. Aspirin, which is acetic acid. This one. All right. You know what's aspirin? What's aspirin? شو الاسبرين يا شباب؟
medical bill.
It's medical tablets that we use if you have headache, similar to Panadol. You probably know Panadol more, right?
Painkiller.
Yeah, painkiller. It is painkiller. Okay, we have this reaction, and in a certain synthesis, 1.408 acetic acid. So we got 104.8 gram of this one. We reacted with 110.9 gram of this one. All right. Calculate the percent yield of the reaction if we produce 105.6 gram aspirin. All right. Okay. So we produce in the lab 105.6 gram. What's this 1.5.6 gram?
Actual.
This is the actual. Yes. Why? Because we said calculate the percent yield of the reaction if 1.05.6 gram of aspirin is produced. So we did this experiment in which we react 104.8 gram of this one with 110 gram of this one, and we produced, so this is the actual yield, 105.6. Keep these numbers in your mind so that we want to do the reaction. So to help you, if you have a chemical reaction like this, as I told you, what's the first step you should do? Write the chemical reaction. All right? And I did it for you. I wrote the chemical reaction. This is the chemical reaction that we just saw a while ago. From the reaction, how much, well, how many moles of this one you need? To react with what?
One more.
All of this one, and to produce?
One.
1 mole of this one, and 1 mole plus 1. So everything is 1 mole to 1 mole to 1 mole to 1 mole. I want you also, we are not reading the question so far. This is just from the chemical reaction. From where I got this number?
From periodic table.
From periodic table. From periodic table, which is the mass of this one. What's this number? The mass of this one. What's this number? Mass of this one. What's this number? Mass of this one. I want you to understand that I'm doing this without, now I did not start the question. Once I saw a chemical reaction, I can relate things by moles. Is this clear? Now, let's go and read the question. I have 104.8 gram of this one. So I will write here, what I have is 104.8 of this one. And I have 110.9 of this one. So I have 110.9 gram exactly of C4H6O3, and they have 104.8 gram of C7H6O3. Now you did it yourself. Go ahead and tell me which one is the limiting reactant. Go ahead. What should I do? Do we have an answer?
Multiply with the 102.09.
Yes, Doctor.
Yes, what is it?
Multiply by 102.09.
Yeah.
One
gram of C4H6.
I know. I want an answer. What's the answer?
Not listen, Doctor.
27.46.
What is it?
77.446.
77.46, I believe you. Who else got the same answer? What should you do? You should take the 104.8, multiply it by, what's at the top?
102.9.
gram C4H6O3, and down?
136.12.
138.12 gram C7H6O3. Did you get the same answer?
Yes.
Yes, yes.
So which one is the limiting reactant? This is reactant 4.
C7.
C7H6O3. Why? Why is it the limiting reactant? Because it will react with only 77. How much extra will be of this one?
33.
22.56.
110
20.
minus 77.46. Give me an answer.
27.33.
23.44.
Yes, 33.44.
33.44. I hope you got it. Yes, it is. Actually, yes. No. 33 point. Yeah. Yes, you're right. All right. Is this clear? Is this clear? So I did the calculation and I found that if I have 104 of this one, I need only 77. That's why, since I have 110, this means this is the limiting reactant. Now, if I want to know how much of aspirin I want to produce, I should do the calculation with this one, not with this one, because this is extra. So that's why I will now go and erase this one. I don't need it anymore. And I know that's what I need is just 77, so I don't need anything of this. We did this already. Now I want to know how much of this one will produce aspirin. What should I do? How much C9H8O4 will be produced?
Multiply by 1. Yes.
What should I do here? Multiply by what? 180.15 gram C9H8O4 divided by 138.12 gram C7H6O3. All right. And what's the answer? I need an answer.
136.70 or 6.
Are you sure? 136?
136.69.
69.7. That's good enough for me. 0.7. 136.7 grams C9H8O4. Who got the same answer?
Yes.
Okay. So what do you say here? What's this? What do you call this number?
The theoretical.
Theoretical yield. Why you call theoretical? Because you got it by what?
Calculation.
By calculation. What was the actual yield? 105.6. So what's the percent yield?
%.
Yes, 77.2%.
All right. Let's hope so. Let's hope that this is the answer. I hope so. Did you get it? So whenever I give you a chemical reaction, first write the chemical reaction. That's the first thing you should do. Write the chemical reaction. Then relate things by mole. That's the next step you should do. Now, if you need, you calculate the amount. So you don't have to do the amount for all of them. For example, this time we did not use this at all. So you don't have to do things which you didn't need. But if you write it, it's okay. And then find the limiting reactant. That's the most important thing. You must find which one is the limiting reactant. So if you have 104 of this one, this time this 104 is the limiting reactant. By doing calculation and relating things together, then from that you find the theoretical yield. Done with this. Now, what do we call this type of reaction? We have many types of chemical reaction. Many types of chemical reaction. Some of them are called combination. Why we are calling this reaction combination reaction? Tell me why.
Because two make a new one.
Because you're combining X with Y to make them one thing, XY. That's called what? Combination reaction. So if I tell you we have a combination reaction, you know that you're reacting both to make one thing. Clear? Good. What's the name of this reaction?
Decomposition.
The opposite, decomposition reaction. Decomposition reaction. Why? Because we are taking one thing, xy, and making it what? X plus y. We are separating these from each other. That's called decomposition reaction. Good. Okay. And what do you call this? I told you, whenever you have organic compound, organic contain carbon and hydrogen, and you react it with oxygen, what will happen?
Burn.
What? You're
To
going
make
to
fire.
what? CO2 and H2O. Any organic compound. Like, for example, if I say C6H6 react with oxygen, I'm not going to tell you what's the products. What's the product?
Water
Yes?
C6.
and C6.
No.
C2.
C3.
And H2O. Is this clear? Okay, let's try one more thing. If I give you C3H7O and react it with water, with oxygen, what will be the result?
H2O.
Yes?
With water.
CO2.
CO2.
Always. What's the result? What's the result?
Water
Same.
with CO2.
So whenever we have combustion reaction, what's combustion means?
Burning.
Burning with oxygen. Burn with oxygen. Then if it's organic and you burn it with oxygen, the result will be CO2 and H2O. I hope this is clear. Okay, let's look at this reaction. What's the name of the first reaction?
Composition.
What?
Combination.
Combination, not combustion. Combination. This is combination. So this is combination. The second one.
Combustion.
Combustion.
What is it?
Also combustion or what? Combustion.
Combustion.
It's called what? The first one, A.
Combination.
Combination. What's B?
Combustion.
Combustion.
Combustion. Combustion. And C.
Decomposition.
Decomposition. So whenever you see a chemical reaction, you should be able to know if it's combination or decomposition or combustion. The most important one of them all is actually the combustion. Organic compound. What do you mean by organic compound? Contain what?
Contain
Carbon and hydrogen.
Contain carbon and hydrogen and maybe oxygen. And maybe O or N. It's possible. Whenever you react organic compound plus oxygen, what's this called?
Combustion.
Combustion reaction. Combustion. What's the result? What's the product?
CO2 plus H2O.
Exactly. All right. Okay. With this, we will finish chapter 3. And before I go into Okay. All right. Okay. All right, I will take attendance now. All right, and the way we will do attendance, I want you to go to should be
It is open.
It is open.
طيب من وين الدكتور ارسلته برا؟
أنا أرسلته من أمس، حطيته على الشات، شوفوا الشات. دخلتوا الشات؟
دخلنا.
اوكي دخلتوا، سووا التحضير الآن. بشير الآن.
وين اسويه؟ ما نجيته.
أنا حطيته في الشات أمس في نفس وين
في رابط فوق المحاضرة. الحين في واحد أرسله في الشات.
الرابط فوق المحاضرة. نعم. خلاص يا شباب خلصتوا؟ الرابط موجود فوق البداية، فوق المحاضرة.
دكتور مو براضي يفتح عندي.
دكتور بس اضغط بريزنت وخلاص.
ايه اضغط بريزنت بس وسلمه سبمت. اوكي you're done.
دكتور.
نعم.
سجل الدخول عن طريق مايكروسوفت بأي حساب، ما
روح، ما يحتاج حساب ولا شيء، انت بس روح لنفس المحاضرة، فوق المحاضرة في رابط، ادخل على الرابط واضغط على بريزنت. ذاتس اول.
ايوه بس انه اول ما اضغط على الرابط يجينا على انه مايكروسوفت.
بحساب الجامعة.
حساب الجامعة نفسه.
حساب ايميل
على حساب الجامعة. نعم على حساب الجامعة. اوكي خلاص بشيله الآن يا شباب.
ثواني بس يا دكتور ثواني. إيه خلاص دكتور.
خلاص يلا مع السلامة. خلاص هذا نسكر هذا الآن. اوكي now let's go back to our discussion.
يا دكتور
نعم.
ما لحق دقيقة دكتور، كنت جالس اسجل دخول.
والله انا اسف خلاص عدينا من زمان وقلت في بقى احد ما بقى.
كنت معك بالضبط بس جالس اسجل دخول.
Okay. Anyway, let's start chapter 4. Chapter 4 right away, and we will go to chapter 4. When we go to chapter 4.
ارسل لك اسمي دكتور على الايميل.
بعدين نشوف بعد المحاضرة. خلينا نشوف. الآن we have reaction in aqueous solution, chapter 4. What's the word aqueous means?
محلول مائي.
Yes, reaction in water. Reaction in water. So we're going to talk about in this reaction how the reaction takes place when we have water as our solution. All right. And to start with, I want to define 3 important words: solute, solvent, and solution. you put solute plus solvent to make solution. You must memorize this word. So, give me example of a solute.
Sugar.
Sugar or salt, NaCl. What's solvent?
Water.
Water.
And you make what?
Solution. Salted water.
Salt solution. That's the meaning of solute, solvent, and solution. You must memorize the word and you know what are they. Okay. When you dissolve anything in water, it could be electrolyte or non-electrolyte. Electrolyte, what does it mean? Electrolyte means what?
Connect the electrical.
Conduct electricity. Conduct electricity. And non-electrolyte?
Do not conduct.
Does not conduct electricity. All right? Does not conduct electricity. That's what we have. Certain solution which is electrolyte and certain solution which is non-electrolyte. If you put sugar in water is non-electrolyte. All right.
So salt with water is electrolyte.
But salt with water is electrolyte. Why? Why do you think this is what's happening?
Because they have ions.
Exactly. Because when you dissolve sugar in water, it still becomes sugar in water, the same thing, and it's not going to conduct electricity. But in ACL, when you dissolve it in water, you're going to make cation and anion. Cation and anion. And this allows the electricity to go through. And that's why this is electrolyte. And this one is non-electrolyte. All right, clear? Okay. When you dissolve things in water, like in ACL, dissociate to make Na plus Cl minus. Why? Because originally in ACL there was a plus charge and Cl minus charge, and they combine together by attraction, and you don't see the plus and minus because they are attracted with each other. And then when they dissolve in water, they dissociate. This become by itself and this become by itself, and they have the charge here, and then they conduct electricity. When you dissolve HCl in water, HCl was not ion. HCl in water was not ions. HCl was bonded together like this. But when you put them in water, this become ionized. It become H plus and Cl minus. We call this process ionize, makes ions. Even though it originally is not ions, but it became ion. But if it's originally ion, we say it is dissociate to make the ions. All right, but we can use the word ionize for both of them, no problem. But this again.
I have a question.
Yes.
Why it will conduct electricity after putting in the water?
Because of the ions. Because the minus and plus conduct electricity. If it's by itself in ACl, if it is solid, this means there is no ion, is not conducting, is not electrolyte. Why?
دكتور
Not electrolyte. It will not conduct electricity. Why? Because there's no plus and minus. The plus and minus is the thing that make electricity go through. So you need to dissolve NaCl in water to make Na plus and Cl minus. And the same thing with HCl. If it's HCl by itself, it's the gas, HCl, it will not non-electrolyte. But when you dissolve it in water, it became H plus aqueous and Cl minus aqueous, and it become now electrolyte.
Doctor,
Yes.
what's the dissociation? I don't understand the first word.
Dissociation or ionization is the meaning is to make ions. Ionization means make ion, ionization. You are making iron out of Cl. Iron, this is iron. Same thing with dissociation in this case. NaCl dissociate to make Na plus. This is dissociation reaction, in which you make Na plus and Cl minus. Also, this is called dissociation reaction.
So it is the same meaning. It has the same.
In this case, they have the same meaning, yes. And it means
دكتور
to make ions. Yes.
does the every acid ionize?
No, we'll talk about this now. Okay, what is the meaning of acid?
extra H.
Anything that dissolve in water. Dissolve in water, first question. If it dissolve in water and give H plus, then it will be called what? Acid. Clear? Clear? Example, HCl. When you dissolve HCl in water, what will happen? What will happen? It will give us
Ions.
H plus.
Yeah.
If it gives H plus, what does it mean?
acid lose an electron.
It's acid. When anything dissolve in water and give H plus, then this thing is called acid. When anything dissolve in water and give OH minus, this is called what?
Base.
Base. Anything that give OH. So acid give what?
H plus.
Base.
OH minus.
If you see in the reaction OH minus, then it is base. If you see in the reaction in the product H plus, then it is acid. Is this clear? All right. Now, we have what's called strong electrolyte and weak electrolyte. Tell me what's the difference between strong electrolyte and weak electrolyte? Yes?
يكون قوي في conducting electricity.
Exactly, strong to conduct electricity. What's weak electrolyte?
ضعيف, low.
Weak to conduct electricity. That's the difference. All right. What makes things strong or weak?
Water?
No, if you have many ions.
Number of ions.
Yeah, the ions.
Ions. If the number of ions is a lot, this means it's what?
The strong
strong. All right. If it is very little ions, then it is very weak. I'll give you example. All right. If I put HCl in water, I will have completely H plus and Cl minus. But if I have acetic acid, you know what's acetic acid? This is called acetic acid. Some people write it C2H3, C2H3, let's have it, C3COOH. This is called now acetic acid. What's acetic acid? Do you know what's acetic acid? الخل. Acetic acid. That's what you drink at home. But you don't drink acetic acid. الخل زي ما هو. You add water to it and then you use it in your salad or whatever. الخل. All right. C3. Now, when you put CH3COH in water, you will find very little amount goes to H plus CH3COO minus. The rest, always this, if there is anything made, it will go back to this one. So usually when we write this reaction, we write it CH3COOH and we write two arrows. One arrow like this and one arrow like this, and write H plus here plus CH3COO minus. What do I mean by this big arrow and small arrow? This means very little of it goes to this side, very little goes to this side, and a lot of it, if this is formed right away, it will always go back to this one. And you will find that 90% or more, greater than 90%, is staying as it is, CH3COOH. Less than 10% is made like this. Less than 10%. Is this clear? And that's why we call this one strong acid, and we call this one weak acid. Why is it strong acid? Yes? Why this one strong acid? Hello?
Because it make many ions.
It will be H plus. All the H plus. Everything here, 100% dissociate. 100% it will be H plus. But this one, the weak acid like CH3COH, why we call it weak? Only 10% will be H plus. 90% will stay as CH3COOH. Is this clear? Okay.
Yes, doctor.
Now, which one will be the strong electrolyte? The strong acid or the weak acid?
Strong one.
Strong electrolyte, because it's strong acid, it will make strong electrolyte. And how about weak acid? It will be weak electrolyte. I want you today to sit down and memorize these are the strong acids. Only these are strong acids.
Okay.
I want you to memorize them.
Okay.
Any other acid, what's the meaning of acid? Acid gives what?
Hydrogen
H plus.
Anything other than this will be what?
Base.
No.
Weak acid.
Weak acid. Yeah.
Weak acid.
Weak. Is this clear? All right.
Clear.
you to memorize this very well, and we'll continue discussion next time. That's why that's the difference between strong acid, weak acid, and this is a strong acid. Look at the light. What happened to here?